The OSI model is a standard proposed by the International Organization for Standardization. It's quite the mouthful. OSI stands for Open Systems Interconnection and sometimes is referred to as the ISO/OSI reference model. Because of it becoming a common framework for students and developers to work and learn from, it has become a huge part of networking. The application layer is the seventh in the model. It is in charge of providing interfaces for applications to access network services. These include network file transfer, message handling, and database query processing. It is also in charge of general network access, movement of data from sender to receiver, and error recovery for applications. Its PDU is called data, and it deals with the HTTP, FTP, SMTP, Telnet protocols, to name a few. It contains all protocols and methods that are categorized as process-to-process communications across an Internet Protocol network. To establish host-to-host connections, its methods use the transport layer's protocols.
The presentation layer handles data formatting information for network communications. It deals with protocol conversion, character set issues, encryption and decryption, and graphics commands. It can compress the data, redirect which forwards requests that can't be handled locally to network resources that can handle them work at this layer. This layer usually goes with the application layer in the FTP or HTTP. The PDU is data. The session layer allows two parties to hold ongoing communications called sessions across the network. It initiates, maintains, and tears down sessions. It controls session identification so only certain people can access session information. It also handles name lookup for logging in and logging off. DNS and NetBIOS work on this layer, as well as client software. It decides which side of a conversation can transmit data and for how long. It synchronizes tasks from one side to the other, and the PDU is also data.
The transport layer provides transmission of data segments as well as the segmentation and desegmentation of the data before and after transmission from one application to another over a network. This layer is in charge of flow control to ensure there will not be an overflow where the recipient receives more data than they can handle. It acknowledges successful data and moves on to the next if there are no errors present. Some protocols allow the transport layer to monitor the segments and resend the ones that fail to transmit. A problem that can occur on this layer is transmitting segments that are too large to travel between users. In this case, the network layer must fragment the segments, which will result in a loss of performance. The network layer is the third layer. It controls switching and routing technologies, determining the best path for the packets to take. It provides the means of transferring these packets from one computer to another. Computer networking routers and switches with built-in routing functions operate at this level. During the routing process, the network layer is in charge of access control. The router must check the incoming packets to make sure they pass quality control before being forwarded. This layer also handles several types of errors, such as incorrect IP addresses, incorrect subnet masks, bad router configurations, and operational errors.
The data link layer, the PDU becomes a frame. These frames are given a header and a trailer. The header contains the source and destination addresses, and the trailer contains the circle redundancy check, which is used to find errors such as duplicate or incomplete signals. If it finds an error, it will request for the PDU to be resubmitted. There are two sub-layers within the data link layer, the media access control and the logical link control. The media access control is used to communicate with the hardware of the physical layer and also assigns it a physical address called a MAC address. The logical link control defines the use and communication of the logical interface points for the higher layers of this OSI model.
The first layer of the OSI model is the physical layer. The physical layer's job is to convert incoming signals into bits and convert bits into signals for outgoing messages. The type of signals the physical layer has to deal with depends on the medium, so wires such as twisted pair or coaxial use electrical pulses, and fiber optics wires use pulses of light. This layer also handles all of the intricacies of transmitting bits from the sending to receiving end. The physical layer tries to guarantee that the entire message will get to the receiving end exactly as it was originally sent by using a series of ones and zeros. This is called encoding. The PDU at this layer is bits. The OSI model helps us understand how information is sent and received in the form of 7 layers. Each of the 7 layers are important in the data transmitting process because each layer depends on each other.